Hallo, Guten Morgen, wir begrüßen euch zur heutigen Tech-Rust, zu unserer Livestreaming-Konferenz. Wir führen euch heute durch den Tag. Ich bin die Manu und mein Kollege Daniel wird heute auch nochmal ins Bild springen. Wir haben heute 8 Talks insgesamt, starten jetzt dann gleich los, also keine Sorge, ich raube dem Johann jetzt nicht so viel Zeit. Wir werden bis 17 Uhr mit allen unseren Talks durch sein. Es ist ein sehr bunter Strauß an technischen Themen und eigentlich kann man es gut zusammenfassen mit wir sind Techies aus Leidenschaft, mögen das, was wir machen und da wollen wir euch heute gerne dran teilhaben lassen. Wir starten jetzt dann auch sofort los mit dem Johann. Johann ist von Stylight, ist dort Technical Evangelist und wird zu dieser frühen Stunde versuchen, uns die Blockchain mal ganz einfach zu erklären. Gut, Johann.
Hello.
Let's start.
All right. Hello, everyone. So I'm going to talk about a really popular subject these days, which is blockchain, and one of the underlying technologies called Ethereum. So a few words about me. I'm a tech evangelist at Stylight. Been working in tech for like 15 years, been in Germany for 2 years, and before that I was in San Francisco. And I also organize a lot of meetups. So today we'll see what this blockchain is, what is Ethereum, and what is the relationship with Bitcoin. Probably everyone has heard about Bitcoin now. So let's see how all those things relate. We will also talk about the basic concept of Ethereum, the wallet, the Ether, which is the currency, and some other things like transaction blocks and smart contracts. Then in the second part we will have a hands-on, so I will show you how to get into this new world, try to launch your wallet, get some Ether, and then run like a Ethereum node on your local machine, write a smart contract, deploy it, and call it. And then we can have also like a few questions at the end. So what do you need? For the second part, you will need like a terminal and a code editor. So let's start by seeing what is blockchain and this Ethereum thing. So blockchain is a technology that is behind Bitcoin. Bitcoin was itself created in 2008 by someone called Satoshi Nakamoto. It's like this mysterious creator that nobody really know who he is. Been a lot of speculation on that, but that's not the point. So the point is that Ethereum is based on these technologies that Satoshi Nakamoto created that powers the blockchain, and it retains some of the same principles, but also adds some new other principles on top of that. So quick overview of what is a blockchain. It's basically a distributed ledger, and a public ledger, so everyone has access to it. It's basically like, you could see it as a registry where you can write something and everybody can see it. And it's distributed. It's impossible to bring down because it runs on like thousands of different nodes. And it consists of an order, an order and timestamp record of transactions. So basically, one block is like a few transactions, and then all the blocks are linked together, forming the blockchain. So the main principle behind that is that you cannot do like double spending, for example, and also you cannot modify a previous block. It's actually really costly. We will see how that works. All those things actually rely on something called a hash. So a hash is algorithm, a mathematical function, which turn data into some kind of fingerprint. And this fingerprint changes every time the data changes. But so like we have an example here. So if we take like the hash of hello from Microsoft, we can see the first one. And if we add just like exclamation mark at the end, you can see that the hash actually really changed. It's totally different. So property of a good hashing function is that it's impossible to deduce the data from the hash, and it's also changed dramatically when you change the data. We can actually give a quick example of that. So here, I will. All right. You can see it's a Node.js function, and you can see this hashing function here. I will run it. And you can see the result. Hash. I will try to make it bigger. Now you can see if I actually change just one element in there and run it again, that the hash is completely different. That's a really important property. Okay, let's get back to our presentation. So, what is a block? As I said, the block bundles all the transactions, and it contains the hash of those transactions, plus some data. We will see what kind of data. All those blocks are linked together through the hash, so one block contains the hash of the previous block. So basically, you cannot change the data in between without changing the whole chain, which is one really important property of the blockchain, unless you mine it all over. So let's talk about mining. Mining is a process that is computationally expensive, or is made computationally expensive by the network, by the protocol actually. So the idea is that when you want to mine a block, you have to guess a particular hash. So the hash needs to match a particular criteria. So let's say, for example, you need, like the protocol say, you need to have a hash that start with 000. Then you need to add some data to your transaction data. So and iterate over it. There's no quick way to do it. It's basically some guessing, so it's a lot of computation. And this little block of data you add to try to guess the exact hash that you need, that match the criteria, is called a nonce. And finding this nonce is called the proof of work. So it's a really important concept, actually, in blockchain to find this, to have this proof of work. It means that the miners actually did their work and computed a lot of data to actually find the criteria that match the hash they're supposed to get. So what can you do with a distributed immutable ledger? You can do cryptocurrencies like Bitcoin. You can also have like another whole world of things you can do, like property titles, for example. In South America, some countries actually start to use the blockchain to write property titles, which was a big problem before, in this immutable ledger. You can do notarized act. So basically, anytime you want to write a document and have a proof that this document existed at some point in time, you can take the hash of the document and write it in the blockchain, sign it, and then you have like a proof that this document existed, was signed by you, and existed at this particular time. You can do, for example, digital certificates and more things that are still being discovered. So let's talk a bit about Ethereum in itself. So we said that Bitcoin was created in 2008. Ethereum was conceptualized in 2013 by a young guy called Vitalik Buterin, who was actually 17 when he created this, when he thought about, an extension of blockchain technology beyond cryptocurrencies. So he launched a crowdfunding campaign in July 2000, and in July 2015 actually launched the first iteration of Ethereum. So the motto of the platform is the next generation cryptocurrency and decentralized application platform. And that last part is actually really important because it's not only about cryptocurrency, it's also about launching real application in an unstoppable machine. And this machine lives on like thousands of different nodes. It doesn't rely on the Bitcoin blockchain. So when I started to learn a bit about like Ethereum and blockchain, I was a bit confused about like what is using what. Is like the Bitcoin blockchain the same as Ethereum, but actually no, it's a different blockchain. It's more modern. It's supposed to be like a blockchain 2.0 platform. And it also uses a cryptocurrency called Ether to actually operate the platform. So anytime you write something on the blockchain, you need to pay the miners basically to, on the network in itself, to actually perform the operation. So the wallet is your entry point in the Ethereum platform. It holds your account. It lets you send and receive Ether, and also let you create and invoke smart contracts. We'll see that it's not necessarily the easiest way to create and invoke smart contracts in this wallet, but just to manage your accounts, it's actually quite good. It gives like a good overview. We can have a quick look at the wallet. So when it launches, it will actually connect to the network, try to see if there's, try to find a node, and then looking for other peers. It's a peer-to-peer network. It will probably download some of the missing blocks since last time I launched it. So the entire blockchain is actually running on each node. So my computer download every time I connect the Ethereum wallet or like another client to the network, it unlocks the missing blocks from the last time. Right now it's just looking for the peers. We can also just launch the application and see what's in there. So as I said, you have the accounts here. You can see that I have, so this runs on a test network. You can see I have like my main account here. You can see some of the transactions I've made. Everything is public, so that's also a huge point about Ethereum blockchain or blockchain in general. The data that you write is actually public. So all the transaction, all the data you wrote in the blockchain can be seen by anyone. And in fact, is downloaded on every computer that is running the blockchain. Here you can see that you can create contract. You can see the balance I have in here. You can switch from one network to another. So if we go through the main network, takes a little bit of time. You can see that's my main network. So those Ether are actually not like test currencies. They are actually Ether I paid for. Yes, we can also see all the contracts that I've been running, all the transactions I've made here. All right. So I said the word transaction a few times. In Ethereum world, a transaction is an operation that actually writes data to the blockchain. And as I said, like every time you make a transaction, you have to pay for it. A really simple transaction is just to send Ether from one account to another. More complicated transaction involve calling smart contracts. So smart contract is a piece of code that actually is written in a programming language. We will see what programming language and how it's written. But basically, the smart contract, once they are instantiated, make something called distributed applications, dApps in Ethereum language. So a smart contract, it's code running in the Ethereum virtual machine. It can hold Ether, it can write data to the blockchain, and it can be also invoked from another smart contract. It's written in a language called Solidity, but Solidity is just one of many languages. It's just the most popular. It's basically derived from JavaScript. So it's quite easy to program in, and we'll see how that works. But first, I will try to give you an overview on how to get some Ether, because that's something I've been personally struggling for when I started to poke around Ethereum. It's like, how do I get my first Ether? So if you want to run something on the production blockchain, you need to basically pay for the Ether you want. If you work on the developer chain, which is this one, Modern, you don't have to do that. You can use like something called a faucet. And this faucet will actually give you free Ether because it's just like some test network. So it's not real in some way. So what we can try to do is, so to get Ether right now, there's no other way than transferring from a Bitcoin account. So if I go there, I have something called deposit Ether. I can type the amount I want to deposit, and then, so let's say I want to do a deposit of, let's go crazy and do 1 Ether. 1 Ether is about 11, it changes all the time, but like between 11 and 13 euros right now. So let's see. Actually, I don't think I'm in the right place. Let's go back there. Okay, so deposit using Bitcoin, that's the one. So I want to pay with Bitcoin. I want to send 1 Ether. All right. And so now I have basically the instruction to send Bitcoin to my wallet. And this Bitcoin is going to be converted into Ether. So I'm going to sign here. If I can manage to remember everything. Maybe not. All right, so there's a 2-step authentication, of course. So I need to use my phone to log into my Coinbase account to verify that it's me. Oh, and I don't really have network, so hold on 1 minute. All right. sending it on the Wi-Fi because the data connection is quite bad. All right. All right, so I'm entering my verification code. Okay, now I need to also authorize the device. All right, so it should be good now. So now I want to send some Bitcoin. So I need to send this I'm going to zoom in, 0.01 Bitcoin so send at the amount I want to send, and that's the address I'm supposed to send it to. So I'm sending from my wallet, and I'm sending the funds. And now you're going to see what happens. So here we have awaiting deposit, confirming, and now things should get into motion. Hopefully it generally takes a bit of time, so we can just keep an eye on it. So now we have green here, so the deposit has been made. Now it's exchanging the Bitcoin to Ethereum, to some Ether. And we keep an eye on this balance here. That should at some point. All right, so now we have a confirmation from the network that the Bitcoin has been converted to Ethereum and it's sent to my wallet. So this will update in a bit. It needs to download the last block to basically get this transaction and update my wallet. Here we go. So we just put one Ether on the wallet. That was quite easy. I must say I struggled quite a lot at the beginning to understand like how I'm supposed to put some effort to have this whole thing working. But hopefully this will save you some time. So let's close that. Let's go back here. So now let's do a hands-on on Ethereum. So we have a web interface that is available. There's actually quite a few web interfaces available. I like one that is called Ethercamp. Let's see how it looks like. I already have it open here. So it looks like that. You can search for a transaction. You can actually search for an account. You can switch network here. So we are mostly interested by those two. Instead is the production network, and modern is the staging network. So we'll actually use modern primarily because it doesn't really cost anything to play with it. So if you want to change to modern, it's just a matter of like clicking here, and we are now on the modern network. So let's see, for example, let's see what's on this account. Actually, not this one, but my modern account. So I'm switching networks. All right. So this is my main account. And earlier I told you that you can actually get free Ether. You might be wondering how. Here actually you can get some free Ether. So if you copy this address, which is basically the hash of address of my modnet account, put it here, you get Ether. It might take a while because mostly it needs to withdraw the account from withdraw the money from an account that has been mining Ether for a while. Anyway, we already have some Ether on the account, so we can do some operations here. So let's take this address, paste it here, and see what's in there. So it's looking on the blockchain, found an account, and this is my account. So you can see that I made 110 transactions in total. That's my balance that you can actually find here as well. We talked earlier about the nonce. So my account is actually part of the blockchain, so it has been mined, and the nonce is like this, as I said, like this part of the data that has to be mined to belong to the blockchain. So your block belongs to the blockchain. All right, so you can have a look at all the transactions I've made. As I said, everything is public. That's a really interesting property of Ethereum. You can transfer some Ether from one account to another. You can go inside a transaction and see what happens there. Like for example, you can see that this one was like a smart contract that called something. We will get to that in a bit. All right. Let's go back here. So as I said, like we have the production blockchain, we have the staging one, and you can also use a local blockchain so you don't actually talk to the network. It's a bit easier when you do coding on your machine, that you don't have to be connected to the network to actually make some tests. So yes, let's start to write a smart contract. So smart contracts, as I said, are written in some kind of JavaScript-like language called Solidity. It supports inheritance, which is an interesting property. It's compiled with something called Sol-C. And you can, of course, use some tooling to compile and deploy your smart contracts. So let's see how we do that. First, you need to have something called get, which is a local client. Actually, it lets you run a node on your computer. So it lets you be part of the blockchain. It downloads all the blocks, pretty much like the wallet, but more like in a programmatic way. So it exposes like an API, and you can interact with your local node, and your local node actually interact with the whole blockchain. You don't interact directly with the blockchain remotely without running a node because the calls are not encrypted. So first you need to get Ethereum. So that's the link. Actually, I have it here. It's quite easy. You just download it and run it on your machine. So I have it installed already, of course, and let's run it. So let me actually go here and do it's a complicated command, so I will just, I have it actually somewhere. All right. Oh, that's a good error. It said it cannot open the database. Yes, because of course my database is already used. My local database is already used by my wallet. So I'm closing the wallet and run it again. And now you can see that it's running. So I have a few interesting parameters here. So anything related to RPC means that I want to communicate from my local computer to this node. And I'm allowing like a few different APIs that I can use. And I also want to unlock my account. So my node can actually have access to my wallet and can start like basically paying for the transaction, because every transaction that I'm going to do needs to be paid for. So I need to unlock my wallet here, enter my password, and as you can see, my account is unlocked. So another thing that I specified, actually I forgot to specify here, but it's if we print this, you can see that I'm using testnet, which is actually the modern network. So when I launch this and want to unlock my account, that's the account you've seen earlier, which contained a few effers that we can play with. So you can see that it's bit verbose. It just says that it's importing some block, it's synchronizing with the network, which is a good sign. All right, so let's see. Now we have an Ethereum block actually running on our computer. So we can start to play with it. One good way to play with Ethereum and start writing smart contract is to use a development tool called Truffle. Doing everything by hand is kind of hard. Truffle really is easy to use to compile a smart contract, create a template, and deploy your smart contract to the blockchain. So let's play with it. We're going to all right, and we're going to invoke Truffle and see what's going on. As you can see, you have like a list of commands. So you can build your app, you can compile your contract, and so on. The first interesting command that we're going to run is called init. Init is basically creating a skeleton for your app. So you can see that you now have like application directory, a contract directory, some environments, some testing, and a JS, or actually a JavaScript description of the application. All right, so what we could do now is look in there. So let's take that. Oops. Open it. All right, so what's interesting for us is mostly right now this contracts directory, where you have two files. So it's basically like some templates, but we are going to play with it and see how we can deploy this smart contract to the blockchain. So this smart contract is quite simple. it shows that one important functionality of the language is like the ability to create libraries that you can reuse in different contracts. And here is your actual contract. So this contract, as you can see, it really looks like JavaScript. We import the library, and then we create the contract. It has one main variable, which is balances. Balances is a mapping, so it's basically like a hash table that match some addresses with like an actual balance, like of virtual money. So when we start the contract, when we instantiate it, we have we set the contract to have a balance of 10,000 something. It's like virtual money, currency. Then we have a function called sendCoin, which, as the name can suggest, let you send a coin to someone with its address and from like a given amount. So what it's going to do is going to check first if you can actually, if you have this money that you want to send, and then deduct the money from your local account, create a balance for this new account on this local contract, and and just return. And then you can also get the balance of the contract and the balance in Ethereum. So now let's try to see how we can deploy that. So first, let's compile it. So we use truffle compile. All right. So now we have like a compiled contract in our like directory that we can actually deploy. So if we do truffle deploy, that's going to take a little bit because we basically talk to the Ethereum network, even if it's that was actually pretty fast. Even if it's a test network, we still talk to a live network, and we ask the network to actually mine the deployment of the contract. So this contract is written on the blockchain, and we can see that it was mined at this address. So now let's see what's there. Found one account. Oh, it's still loading. Okay, so one transaction. This is basically your smart contract. So, but it's actually hard to see what's in there. So we can actually. I made a mistake. That's actually the address of the contract. So what we found was just another transaction. If we go there, we should find the contract. All right, and you can see that there's some keys there. And of course, we have this address, which is our local Ethereum address of our wallet, and the associated balance that we set in the constructor of the function. So what we can do here to make it more easy, we can attach the source code. So we need to attach both of them and name it. Oh, actually, it's MetaCoin. And it upload. Contract has been uploaded. So we are basically attaching like the source code of the contract to its actual representation on the blockchain. So here you can see that now we also have a name for this data member, which is called balances. All right, so we have deployed our contract. Now let's try to call it. So I have something ready that we can use. Here I have a simple function that I will import here. That is getBalance. So what getBalance does is, so it's JavaScript application. We can run it with truffle, and basically we can get the balance on a given address. So as you see, that's the address of my wallet. So let's see what's in there. So basically, if we go in there, we can see the source of my contract, and what we're going to invoke is this function in particular, the getBalance function. So it takes, in argument, it takes like an address, and this address is the one is my local address. So, oops. So right now in the contract we have, yes, my local address here. So let's invoke this. Oops. Metacode is not defined. All right. So I can switch to actually another thing that I have ready. Oh yeah, actually that's the hiccups of live demos. Thanks. Oh. All right, so I do truffle exec, actually, not calling directly the node application because it doesn't have the necessary libraries. And when I do that, as you can see, I basically execute this code which returns the balance of my contract. So you can see that here I retrieve the balance, which is 10,000, and that's it for this part. So what else do we have here? We have covered the deployment of the contract, making a call. We could make a transaction. Also, like a transaction is basically writing data to the blockchain. So in our case, it would be to invoke send coin. I will leave you do that, and we can also like pretty easily build a front end. So I will just like really quickly show you that. So you can do like a truffle serve. You have an application that is actually generated automatically, and you can play with it really easily. So you can say, I want to send 100 meta currency to like a random address. And then it will mine this and actually execute the transaction. If we go to our get client, we can see that actually this line is the actual transaction that went through. All right, so we covered the basis. And now maybe we have some questions.
Yes, one.
Mm-hmm.
So thanks, Johann, for your talk.
Mm-hmm.
So
Sure.
maybe we now
Pleasure.
have kind of an idea what the blockchain does and can get hands-on with it. But I think I have to rewatch the video afterwards. Okay, so the question is, what do you think will the blockchain impact mostly in the next 1 or 2 years? Will it just be the fintech sector?
Not necessarily. Like I think anything that has to do with like a centralized institution can be disrupted by the blockchain, because blockchain is a way to actually run like trustworthy transaction in an untrusted network without any central institution to actually take care of it. So banks, of course, is one at fintech, but as I said, like you can think also like all the notarized act. Yeah, and a lot more to come.
Okay, so exciting times for
Yes.
us. Okay, thanks, Johann.
Thank you.
Thank you. So, dann geht es auch gleich weiter in ein paar Minuten mit dem Alex Repti. Der wird uns eine tolle Geschichte erzählen, wie er quasi von 0 auf Game Dev in 7 Wochen gekommen ist. So, ein paar Minuten geht's weiter. Dranbleiben.